when we started looking at number systems, it was kind of confusing. So I'll use this video to kind of explain the basics. So the number system we've grown up with is decimal. It's base 10. So when we count, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we repeat. 11, 12, 13, 14, 15, 16, 17, 18, 19, and so on. And the reason that works is because it's based on the number 10. By based, I mean this. This chart shows us. When we think of the number 427 in decimal, we know that it's 7 ones, 2 tens, and 4 100s. And the reason it is because the base is 10. 10 to the 0 is 1, makes the ones column. 10 to the 1 is 10, makes the tens column. 10 squared is 100, makes the hundreds column. And 10 cubed is 1,000, makes 1,000, and so on. And that's the system we're really used to. So when we see the number 427, we know it means 4 times 100, 2 times 10, 7 times 1. So when we get in the other systems that we start kind of going, hey. Let's look at octal as an example, base 8. The only numbers we get to use are 0 to 7. There is no 8, 9, or 10. So if we're counting 0, 1, 2, 3, 4, 5, 6, 7, then 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, then 2, 0, 2, 1, and so on. Same rhythm, just different numbers. And the reason for it being called base 8 is, just like decimals, 10 to the 0, 10 to the 1, 10 squared, our columns are 8 to the power of 0, 8 to the power of 1, 8 squared, 8 cubed, 8, and so on. So that makes this the ones column, this is the 8s column, 8 squared is 64, that's the 64's column, and so on down the line. So, if we were to look at the number 357 as a base 8 number, notice the subscript tells me that it's a base 8. And we want to know what it is in base 10. If I put 357 on this chart, that means there's going to be 7 ones, 5 8s, 3 64s. When you work that all out, it's 192 plus 40 plus 7 is 239 in a base 10 number system. So 357 base 8 is the same as 239 base 10. Let's look at the other two that we considered. A base 2 or binary number system has only 2 digits, 0 and 1. So when we're counting, we go 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and so on. How it works, same as the other two number systems. You've got a ones column because 2 to the 0 is 1. Then 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16. That's how we get the values of our columns. So we've got a 1's column, a 2's, a 4's, an 8's, a 16's column, and so on. So if we want to take the number 10011 as a base 2 number and find its base 10 equivalent, we plug it in, 10011. So that's going to be 1, 1, 1, 2, and 1, 16. Add those all up, you get 19 base 10. So 10011 as a base 2 number is 19 base 10. Hex is the one that really messes with people, and the reason is we're counting with things that aren't numbers. So when we're counting in decimal, I've got that in black here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In hex, that'd be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then, because we need a single digit, A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. The next number after F would be 1, 0. Then 1, 1, 1, 2, 1, 3, 1, 4, 1, A, 1, B, 1, C, 1, D, 1, E, 1, F, 2, 0, and so on. A little harder to wrap your head around. But again, it works in the same fashion. You've got a 16 to the power of 0 column, which is 1, a 16 to the power of 1 column, which is 16, 16 squared column is 256, and so on. So if I wanted to take the number 1A3 as base 16 and make it into decimal, I'd plug in 1A3. That'd be 3 times 1, 8 times 16, where A is 10, so 10 times 16, and 1 times 256. Add those all up, 256 plus 160 plus 3 is 419 base 10. So 1A3 as a base 16 number is 419 as a base 10 number. That was an awful lot in one video, but I wanted you to see the different number systems and just get a little taste of it. We'll do some more detailed conversions in our other videos.